Hi, today I'll show you how to create the up-down counter uh, using Proteus and coding with microC Pro for PIC, the version 5.0.1. Right, I'll start by demonstrating the code and explaining each line to you. Okay, let's start from the top. And this first line here, I created an array that will take 4 numbers. Okay, first of all, I am going to create a counter that counts up and down using 2 switches. First, the up counting part of the code, it must count evenly, like 2, 4, 6, 8, 12, etc. And then the down counting part of it, it must count 1, 3, 5, 7, 9. But it must count down, not up. So this part, it's the up count evenly, and this is the down count oddly, something like that. Yes. And here I declared my 2 switches. Switch 1, it's for counting up. Switch 2, it's for counting down. So these are the switches that I'll use to control the whole process. And then here I have my flags. I'll show you how this works throughout the code. And then you start by the void init or initialize. Here you initialize the traces of the ports, whether it will be an output or input. So trace A, it will be an input, and trace D will be an output. Right. And then we move to the next line, which is this is the main function. This is where the main function starts. It starts here. So this is one function. And I move to void main. And then first of all, I call this function here. Or you can declare these things here. It doesn't matter. It will work perfectly. And then the next line, we move to ansel h ansel, because the ports are analog, so we have to convert them to digital. So here pins are converted to digital. Yeah. Same goes for here. Pins are all converted to digital. Ansel H for the higher pins and ansel for the lower pins. Next line. Right. In C, you need to have this do while. This is a do while loop. This will keep looping the program forever. So this is like an endless program. It will keep on looping itself because while is 1 and I'm not incrementing it. Okay, then the first test is that we make switch 1 equals to RA0, the 0 bit of port A. So here we do our testing. If switch 1 is high, then flag a 1. I've already constructed the circuit. As you can see, I'm using a normally open switch, so that's why I'm flagging it, because if I don't flag it, this switch, it doesn't stay continuously on. It needs to be pushed to stay continuously on. So for example, as you can see, I need to keep pushing it, but it doesn't stay on its own. So I need to flag it and clarify and show that this must be high. Right. Next line, into the if statement, and then we test again if this. The first if statement says if switch 1 is high, make flag 1 high, and flag 1 if flag 1 is high. If flag 1 is high, then do this. I declared 2 variables here. first for the increment. This increment I'm going to use in a for loop to increment it to 3. In this case, I'm counting from 0 to 3, and I'm going to increment that 0 here. I'm going to increment whatever it's here. So I'm going to take what's in here, bring it here, and whatever that's in here is actually equals to index, and index is equals to port D. And port D on this sketch, port D is connected to a decoder, which is connected to a 7 segment of a common anode, right? And then all those values, they'll be brought here, but they'll be decoded first to binary, and then because it's BCD 0 to 9, these numbers will come to A, B, C to D, and then they'll be decoded here to binary, right? Then move to the next line, and then it'll delay for 100 milliseconds, and then if flag 1 is still high, it will keep on doing this, it will keep on looping this until the next condition is on. The next condition is switch 2 is equal to array 0 bit also, array 0 bit, and then if switch 2 is high, then do this flag switch make flag 1 a 0 and make flag 2 a high. In this case, I'm actually differentiating between the two conditions of counting up and counting down. This was for the counting up part, so I'm making it 0. If it's 0, this condition here will be invalid from here, because this testing here, it tests if it's high, but if it's low, this thing will be false and it won't be executed. Then this part will be executed because flag 2 is high. If flag 2 is high, and then do this, you'll take 4, and if 4 is greater than or equals to 0, decrement it. Therefore, it will count down. Yes. Then it will say index is equals to odd, and the odd it's equals to inc. So it will decrement after 100 milliseconds. After every 100 milliseconds, it will decrement 1 from the 4 till it's 0. And then this part, as I said, it will keep on looping the program. Now let's load the code to the pig. Change. You go where your project is, you add the hexa file, you look for the hexa file, and you edit. And then okay, you're good to go. Then play the program. Program is cool, everything is fine. Then if I press once, it will count up in an odd way, 2, 4, 6, 8, and it'll keep on counting 2, 4, 6, 8 until I press this button again. If I press this button again, it'll count down 9, 7, 5, 2, 3, 1, and 2, and I pressed again, it's counting up now. So yeah, this is it, guys. This is how you combine proteus and